Determine the following probabilities as percentages rounded to 4 decimal places. For the first example, Crammond is creating a 7-digit passcode using the digits 0 through 9. If Crammond chooses all of the characters at random, what is the probability that no digits are repeated? Let's begin by working on the denominator, which is equal to the total number of outcomes, or in our case, the total number of possible 7-digit passcodes using the digits 0 through 9 if repetition is allowed. So let's go ahead and model this. We have 1, 2, 3, 4, 5, 6, 7-digit passcodes. If repetition is allowed using the counting principle, there are 10 ways to select the first digit, 10 ways to select the second digit, 10 ways to select the third digit, and so on, giving us a total of 10 to the 7th possible passcodes. Again, when repetition is allowed. So that's the denominator of the probability, which is the total number of outcomes, or total number of 7-digit passcodes using these digits. And because we're looking for the probability that no digits are repeated, we now need to find how many passcodes are possible if repetition is not allowed. So if repetition is not allowed, there are still 10 choices for the first digit, but then since that digit cannot be used again, there are only 9 choices for the second digit, 8 choices for the third digit, 7 choices for the fourth digit, 6 choices for the fifth digit, 5 choices for the 6th digit, and finally 4 choices for the 7th digit. Again, this is if repetition is not allowed. This product is equal to the favorable number of outcomes, or the numerator of the probability. We could have also used a permutation here and determined 10 permute 7, but I think this approach makes more sense. And now let's go to the calculator. Let's click the fraction key, and then we have 10 times 9 times 8 times 7 times 6 times 5 times 4, tab. The denominator is 10, and then we press the exponent key here into the exponent of 7, and enter. To convert the decimal to a percent, we multiply by 100 and add a percent sign. Which gives us 6.048%. We were told to round to 4 decimal places, but here we have the exact percentage in 3 decimal places. For the second question, 3 cards are chosen without replacement from a deck of 52 cards and placed in order from first to third. What is the probability that all 3 cards are 5s? I think the easiest approach for this problem will be to think of this as 3 dependent events, and therefore if we find the probability of each event, we can simply multiply those probabilities together to find the probability of 3 5s. So we first find the probability that the first card is a 5. Well, there are 52 cards, 4 of which are 5s, and therefore the probability the first card is a 5 is 4 divided by 52, or 4/52, times, now we multiply by the probability that the second card is a 5, given the first card is a 5. Well, now there's only 51 cards, 3 of which are 5s, and therefore the probability the second card is a 5, given the first card is already a 5, is 3 divided by 51, or 3/51. And then we multiply by the probability the third card is a 5, given the first 2 cards are 5s. Well, now there's only 50 cards, 2 of which are 5s, and therefore the probability the third card is a 5, given the first 2 cards are 5s, is 2 divided by 50, or 2/50. And now let's go to the calculator. 4 divided by 52, tab, times 3 divided by 51, tab, times 2 divided by 50, enter. Here we have the probability as a decimal. To convert to a percent, we multiply by 100 and add a percent sign. So we have times 100. And now we're told to round to 4 decimal places. Because we have a 9 in the 5th decimal place, we round up to 0.0181%. I hope you found this helpful.